Let us understand how to write equation of planes in Cartesian form. So we are given the equation pi, the plane, is equal to x equals to 3 plus s plus t, y equals to 3 minus s, and z equals to 3 plus t. Now to write it in Cartesian form, let us first write it in vector form, right? So in this example, we will actually see all the different forms of writing the equation for a plane. So that is the beauty of this question. Now as you can see from here, the point which we are considering is 3, 3, 3, right? So I can rewrite this equation of plane as equal to, so we are considering a point which is 3, 3, 3. So let's say the point is 3, 3, 3 on the plane. Now for this particular point, first parameter is s. Now that is the parameter of s, and we can say there is a line on this plane with this parameter s, and the direction number should be 1, minus 1, 0, since there is no s here, right? So we can write this as 1, minus 1, 0. Plus t is the second parameter, and the direction number is 1, 0, 1. Do you see that? 1, 0, and 1. So that is how we get the vector form of the plane equation, correct? Now we will see how to write the Cartesian form. The idea of this question is to make you conversant with all the three forms. To find normal, which is important to write the equation Cartesian form, let me remind, Cartesian form means what for us? Cartesian form means we are writing equation in ax plus by plus cz plus d equals to 0. So that is the form in which we want to write the equation. Now a, b, c are part of normal vector, right? So we can get the normal vector from here by cross multiplying these two direction numbers. So we can get it by 1, minus 1, 0, cross product with 1, 0, and 1. So that will give us the normal, or the values of a, b, and c. So let's do this, right? So to find, well, we can apply this method, which I really like. That is, let's start with the center number, which is minus 1. Let me use a different ink. So we'll use minus 1, 0, 1, and then we'll end at minus 1. For the second number, starting with the center, 0, 1, 1, 0, right? Now the three parts are, this is our I component, this is the j component, and that is the k component, right? So we can write down now normal as equals to, so we get normal equals to, I component is minus 1 times 1 is minus 1, minus 0, so it's just minus 1, plus j component, so let me write them as vectors, unit vectors, 0 minus 1, so that is minus 1. And unit vector k can be written as 0 minus, so it becomes plus 1, correct? So that becomes the normal vector, which is minus I plus times minus is negative, so minus j, plus is plus, plus k, right? So that gives us the normal, and since this is normal, we can say or write it in the other form, which is minus 1, and 1, right? Now we can replace a, b, and c with these normal vectors, and then find d by substituting the value of the point x, y, z as 3, 3, 3. So that is the whole idea, right? So what we really get is that the vector equation will be minus x minus y plus z plus d equals to 0. So that is the equation which we get for the time being. Now from here we are going to move towards the left side, kind of I will do this side, right? And we'll figure out what is the value of d. Now to find the value of d, we'll use the point, and the point for us is 3, 3, 3, right? So the point is 3, 3, 3. We'll use this point in the given equation, and then find the value of d. So let me use this. We get minus 3 plus 3 plus d equals to 0, right? So that gives us minus 3 plus d equals to 0, or d is equals to 3. Now since d equals to 3, we can write down our equation, and that is minus x minus y plus z plus d, which is 3, equals to 0. So that becomes the equation of our plane in Cartesian form, right? So that is how we should write it. So our answer is that the Cartesian equation is minus x minus y plus z plus 3 equals to 0, right? So that is the answer. So we actually start from here, and then we move towards the left side. I hope the solution is absolutely clear. The idea is, if you are given the parametric form, get the direction numbers, cross multiply them to get the normal, use the point to get the equation. So these are the steps to be followed to get the equation of a plane in Cartesian form. Thank you.